So the only thing I did without the video on was we made the scatter plot. It shouldn't be any issue to guess which is your explanatory and which is your response. I set our numbering for our axes just so that they look the same. For now, I want it, your title is scatter plot of X versus Y for population. Eventually, we'll kind of shorthand that, but not yet. So now we are at the point where I want to talk about all the calculator stuff for what we just did and what we're getting ready to do. So your X values are in list 1. Your Y values are in list 2. So yours should look like this. What do we want in list 3? How do we find our predicted? All right. So by plugging in our X values into our equation. So first of all, we need the equation. And I'm going to show you 2 different ways to do this one. How do I get to the equation? Stat, calc, which number? 8, because it's the A plus BX, not AX plus B. And it prompts me like this. What's my X list is list 1, my Y list is list 2. You don't enter anything else, and you hit calculate. And it gives you your intercept, your slope, your R squared, and your R. So how do I use that in my lists? So if I were here, tell me what to do from here. Go up, so you're highlighting list 3. And then what would I type in there? So 32.0669049, what? Plus your slope value 0.6742108398. And then what do you plug in as X? L1. It's just the ones that are, it's still up there. And so when I do that and hit enter, it is going to come up with my entire predicted list for me for each one of my X values. And so that's just using my equation to get that list.
And we plug in list 2?
List 1, because you plug your X's in as your X. And so your value should look something like mine. These numbers should be somewhat relatively close to what? So your list 3 should always be similarly relative numbers close to what? L2. Now, these are all about the same, so that's not a good way to check it. But sometimes I have people where the X values are between like 1 and 12. Their Y values are between like 80 and 100. And they get predicted values that are like 15 to 20, and they don't see any issue with that. You should see issues with that. So they should be similar, like kind of to list 2, if your model is halfway decent at all. So I've got my expected, my predicted in list 3. What do I do from here? Go to list 4. Grab one of those off the top right there. And I want my residuals in list 4. How do I find that? L2 minus L3. Oops, hit the wrong button. L2 minus L3 while I'm highlighted there, hit enter. And so that list is now my residuals. Please tell me I'm recording. Where did the button go? Oh, it's just hidden. Okay, good. let's go ahead and draw our equation on this line. Let me go ahead and show you the thing to do with the calculator. I'm going to go back. Delete your list 4 and your list 3. Some of you are going to prefer doing it the way I just taught you, and that is absolutely fine. To be honest, until yesterday, I didn't know you could do it this way, as much as I deal with this stuff. So let's go back in like we're finding out what the equation is again. So go to Stat Calc 8. And there is an option that says Store Regression Equation. That one that's all the way except at the bottom. This is where you have to do a little bit extra if you want to do it this way, but it's a lot less typing. So have your cursor where it says Store Regression Equation right here. And then you are going to have to go to Variables, which is like where we go to Distribution, but not hitting second. So Variables, and you go over to Y variables. We want to save it as a function, so hit 1. And we're just going to make it Y1. Yeah. And then so just hit Y1 so that now here it says you're going to store your regression equation in Y1. Do I need to go back over that for anybody?
You go to Y variables and then
you go to variables, you go
Y variables.
Y variables, and then function, and then the first, just click on Y1. All right, so now hit calculate.
But if we deleted our list 3 and list 4, then how does it get it?
It doesn't need list 3 and list 4 to do it. So when you hit enter, it's going to look the exact same way it just did. But now I can apply that function that I just created to a list. So now go to Stat Edit and be at list 3. And I go back basically where I just went. So variables, Y variables, function, Y1. And don't hit enter. We have to put what our X's are. So you do parentheses, list 1. So I am applying function of Y1 with my input variable of list 1, and it fills the whole thing for you. The other thing that's good about that is if you ever want to predict any number, whether it's in your numbers or not, from that equation, you can always do it at any point. So if I'm here and I want to know, well, what happens if somebody had a test average of 78? I could go do it the same way I just did and do variables, Y variables, function, Y1 of 78. And it tells me that they would be predicted to have an 85. Some of you are going to want to do it that way, and some of you are going to be like, that's too many steps. I'll risk typing in a bunch of numbers. I don't care which one you do. I'm just showing you both methods. All right.
I don't understand how you use it after you do that. I don't know what you said, but
Here.
yeah, like
It would be very possible for me to give you a question where it says, if someone were to get a 78 on their test average, what would you expect their whatever to be? And that's when you would use that. And you would have to type the whole equation in by hand again if you wanted to know that, if you didn't have it stored as a function.
And do you have to do it on a list, or can you just...
No, so like that was just in calculator from the beginning. The other thing about it is, go to your Y equals. Is there now an equation there? Which means when you graph it, it already graphs that line for you on the graph. So there's definitely some good to using it, but there are also more steps involved to remember. So totally up to you whether you want to use it or not. All right. So either way, let's go and make sure fill in your list 4 again from what you have. So list 3 minus list 2, or list 2 minus list 3. So what is now in our list 4? Residuals. So where we are in our notes here, we wrote our list 4 is going to be in our residuals. So off to the side, like I wrote here, you would graph list 1 versus list 4. Here, I want to write, you graph what?
Where did we do 1?
List 1 versus list 4. There, I wrote, to get a scatter plot, you graph list 1 versus list 2. So here, right.
But to get list 4, we did list 2 matches list 4.
Yeah. Alright, so now we know how to get it and stuff, but I want to kind of talk about what actually happens here. The basic idea of what actually happens is I have this line. Oh, so if I want to draw the line on my graph here, and I already have it stored as a function, you know how we have to plug in 2 numbers to figure out where a line's going to be? So I could do that. I would write this under paper. I would type in like for 66 and get a number, and then I would type it in as by 96 and get a number. Do that on your calculator so you can see what I'm talking about. So just in calculator itself, not the graph. Go back to function. So variables, y variables, function, y1, parentheses, type in 66. And what do you get?
76.5648.
So at 66, 76.54, it's going to be about right here. That's where my line's going to start. And then if I plug it in for 96 instead, I get what? So about right here. So those are my endpoints now to use to make my line. Alright, so what happens when we're getting to residuals plot is a residuals plot is kind of the crooked zoomed in version. What really happens here is we take the perpendicular to that line that I just drew. Don't draw on this. This is the idea of what happens in the background. It's basically saying I now take some perpendicular line and take this whole graph and turn it sideways. But this is still going to be our number line, so it's not exactly what that is. But you're basically going to look at it crooked like this and zoom in. So it might look linear, but when we turn it crooked and zoom in, does it still look linear, or does it look like there's something going on there? So go ahead and in your calculator.
When we do our list,
Yep.
I mean our line, do we go past the point?
Yeah, you can go past the points. So let's let our calculator graph it for us, just so that we have an idea of what we're looking at. So second stat plot, list 1 versus list 4. Oh, I've got to turn my y equals off because it's still trying to do that. So I just did a second stat plot of list 1 versus list 4. That is my residuals plot.
Can you go back? Can you start over the graphing? You did really fast.
What? At what?
I lost you when you started graphing because I was still doing.
All I did is graph list 1 versus list 4. So second stat plot of list 1 versus list 4.
How do you do verses?
No, so like when you go to second stat plot, it asks for X list is where, and your Y list is where. Your X list I want is list 1. Your Y list I want is list 4.
And what are we graphing?
That is our residuals plot.
Is that going to be the blank one at the bottom?
Yeah.
Yeah. So you turn off the line. You just click on the line. Mine's still showing.
So right now, those of you who have a Y equals and that's being an issue, do you see where I am in my Y equals? Do you see where the equal sign is highlighted? If I click on that equal sign and actually click on it, it unhighlights it, which means it's now not graphing it.
What?
Here, I was graphing my y equals, and here I just click on the equal sign and it makes it not graph anymore. If you had a line going through yours.
We don't want it line. And how do we get there?
Y equals. Top left, yeah.
So do we need to remember to do that every time? To go to y equals and...
That's if you do the regression, if you store your regression equation, it does it on purpose. It does it by default. I'm going very slow on purpose. Once you do one of these on your own, this will become very easy. I can promise you that.
How did you get it off the equal sign?
You take your cursor to the equals and literally just hit enter, and then it'll take it off. All right, so our residuals plot is now going to look like this. That's right here. This is what we're getting ready to graph. We are going to graph it on our paper by hand, kind of by hand. I can either take my list or my graph and do trace and do it that way to where I'm sitting here going through and tracing with every point, or I can be looking at my list 1, list 4 together, whichever way you want to do that. I think it's easier at this point to do trace. Like right now, this point's highlighted, which is an x value of 69 and y of 1.41. So let's graph this together. The thing about a residuals plot is what goes on the x-axis. In general, what always goes on the x-axis of a residuals plot? Your x's. So the way you numbered this is going to be the exact same way that you numbered this on the x-axis. It goes in the order that you typed in there. That makes sense. And so these are still our Q2 test averages. What do we know is going to be our label for our y-axis? Residuals. This is our residuals plot. Again, I told you I'm going to shorthand this eventually. Of Q2 test average versus Q2 grade for the student's class so they can content. Now, I have to, again, decide how I want to renumber my axis for residuals. Where are my residuals? List 4. So I'm going to look at basically how low I need to go and how high I need to go and kind of go from there. So I definitely need to go all the way up to at least 1.4 and at least all the way down to negative 1.5. For the sake of us keeping these all the same, I went by 0.3 for each one. So I think it is easiest at this point to be in my graph using trace when I graph this. So I'm in my scatter plot of list 1 versus list 4. When I hit trace, it's going to be highlighted on the very first number that I plugged in, which was 69, which was a residual of 1.41. When I go to the right, it goes to the second number I plugged in, which is an x of 69 and a y of negative 1.587 and so forth. I would use that when you graph on here.
Just use trace.
Yeah. And I'm using what I drew earlier, so I'm hoping I'm close. I don't have the numbers actually in front of me. So it should end up looking something like that. I already had it graphed. I just pretended my graph was right. If I had two x values of 69, why do I have two completely different points on my residuals plot for 69? They had two separate values, so how far their value was from what I predicted it to be, even though my predicted would be the same for both of them, they didn't get the same thing. So I'm still going to have two different values. That's fine.
Can you say that again? Sorry.
I have two values whose x value are both 69. Mm-hmm. When I predict them, my prediction is the same. But I have two dots on there because what they actually got was not the same. So their distance from what I predicted was different.
How would you know they were different?
Like, you know, when you see it at the beginning. Like, your first point was 69.80, and the second was 69.77. So, like, both of their x's were 69, but they had different y values. Yeah.
The only thing wrong with the graph is the bottom point.
Oh, this one, I changed my y-axis. Thank you. This should be what, here?
Yeah.
I changed my scale. I forgot about that. Was it 69 and, oh.
It was negative 1.59, so.
Okay. Yeah, thank you. So that was the only one?
Yeah.
Okay. Alright, so I want to write a couple things over here. Not much for this one. For this one, based on the scatter plot, the relationship of x versus y is two things. So just based off of this scatter plot, what does this tell me about the relationship? It's probably strong. I can't definitely tell the strength by that, so I'm not going to write it, even though we can tell it's pretty strong. What else? And positive.
Oh, are you back up to our top one?
Yeah.
Oh.
All right, now our second one, I'm going to check the three things. What's the first thing that we need to check to see if it has? We just wrote it over here. What? No pattern. Can you look at this graph and tell me that there's a pattern that is definitely occurring here? So, like, you see something occurring. No. So, looks good. There's no pattern. And I told you I'm still going to go over these a little bit more. Scattered equally. above and below 0 for all values of x. What that means is the deviation throughout is similar. Now, when I'm on the left, I deviate a lot, right? When I get to here, do I deviate still that much? But why is this one not terrible? What did I tell you about what I gave you versus what I should have given you? That's not very much, right? It's like if I take one out, does it look like the deviation really changes so much? So I'll show you what we're looking for when we end up doing those.
You say below and above, you mean just that line for the middle?
Below this. Yeah. The same way mean works like tug of war, pulling back and forth. That's what's actually going on to make this line also. This line, so this is your least square regression line, right? And we said you turn sideways and then zoom in. So what was our regression line is actually now our x-axis. So this x-axis is the least square regression line from this graph. That's just what I said, you turn sideways and zoom in. What's our last thing we're checking for? Relatively small residuals. That's always going to be a context problem to problem type thing. So basically what that is saying is this first person, I mispredicted their grade by less than 0.3. Well, I rounded their grades to a whole number, so that's probably not that much. This person, I mispredicted their grade by less than 1.5. This person, I mispredicted their grade by a little bit more than 1.5. If I mispredicted your grade by 1.5, did I really miss it by that much? That's what this is meaning. If we are dealing with something like GPA, would these be okay residuals for a GPA? If I missed your GPA by 1.5 points, that's not good. So this always changes based off what the context is for our Y. That's what that is asking about. That's what relatively means. Right. Questions on any of the stuff that we've gone over right now? Let's split it here. Okay.